We'll start today's lecture. And in today's lecture, we will be discussing some portions of the geological work of streams. We discuss about streams. This is a very old concept you all must have studied in your school level, the water cycle, where the water from the ocean which evaporates and it forms clouds, it precipitates, and the precipitation, some part of it is converting into ice and forms a part of glacier. Some part of it started flowing through the surface as a process, and it is surface runoff, and it reaches the sea, and some part of that which will be absorbed by the soil which infiltrate and it moves as a groundwater, and some part of it which will be used by plants or plants, and that will be transpiration process from the plants and it reaches the atmosphere back. So this is a complete cyclic process of water which is on the surface of the earth. And today we are going to discuss about this part, that is the surface runoff part, and after this we will discuss briefly about this groundwater process also. So when water flows through the ground, that also we'll discuss in the later phase. This is what the topic we are going to discuss today. And when the water which is on the surface of the earth which flows, and what kind of things which are produced, what kind of landforms or features which are produced by these streams. Okay, so if you see a stream or a river, it originates from a hilly terrain, okay, and it flows through the different landforms, and finally it reaches the sea. This is the total life of a river. And if you see the longitudinal profile of this river, this we can divide basically into three parts. The first part we call it as the head region, the second part we call it as the middle region, and the third part we call it as the mouth. So the activity of river in this all three different parts are different. Like if you see it in the head region, where the slope is very high, and the flow of water, the velocity of water, the activities of water, the energy of the water will be very high in the high land region or the head region. So in that region, the river is more dynamic. It is capable to carry large amount of loads, large amount of sediments. It can be able to erode, and it can able to transport to the foothill or the base of the valley. So in this part we call it as the head region, or we call this region where the river activity is in youth stage, that it is very dynamic stage of the river. Okay, so it reaches up to some part in the middle of the river. When it reaches, where what happens, the river reduces its capacity. Here in this part the slope is very high, river is capable to carry large sediments. But when it reaches into some part, when we crosses at some slope level, then the slope of the river gradually decreases. So here the slope was very high, but when you come here the slope is reduces, and as a result the slope reduces, the river will not be able to carry all this high amount of load which is carrying from this part. As a result, it will start depositing the sediments here, and it will also take some meandering channels. Meandering channels means it is nothing but it is the channel which is flowing through this curve nature. Because of the change in the slope, the river is not able to flow or carry the load, so it actually takes a curved path, and in that stage we consider the river is in the mature stage. Okay, so in the youth stage, the river is capable to do a lot of work. It is highly energetic, highly dynamic. But in the case of mature stage, the river is not capable to carry all this high amount of load. Rather, it will be selectively transporting the material, and in this stage the erosion activity will be very high. And in this stage, in the case of middle stage, where the erosion deposition processes would be matching, so there would be almost the same amount of erosion depositional processes. But when it comes to the very end of the river, at this stage we call the river is in the mouth stage, or the river is in its old stage. The old stage because the river in this part is not capable to carry all its load, rather the process of more activities of deposition, because the part will become almost horizontal, and it will be in uh, meeting the sea. So at this part the river is very gently sloping, and the amount of materials which are transporting from the high head region to the middle region, and it is more dominated by the deposition of that material. So this part we call it as the mouth stage, or the old stage of the river. So this is what a river which we are talking about. And if you see the cross section of this river, this is the river in it, the this part at the head region. So if you see the cross section, the river valley, this is the river valley. The river valley is very narrow, and it is bounded by hard rocks. Hard rocks means it is highly compact and dense resistive rocks. Whereas it comes to the this region where it is the middle region, or the intersection of middle or the mouth and the middle region, where the river is flowing in a wider valley. The valley is very wider, and the water is, if we see that um, it is flowing through the valley which is wider in nature. Okay, so this is the area, and this river, if it is flowing in this part, it doesn't mean that it will only flow in this channel throughout the year. There are number of cases that this channel may shift from this part to something like this. So water will be flowing on this channel, or sometime this may flow on this part, sometime it may flow on this part. Or what I'm saying is that the channel which is flowing right now on this channel will have different processes. It may shift the channel anywhere in this part. Some area it will flow on this part, this is one area, and when it comes to other part, it may shift from this part to this part. So this kind of changes in the river are possible in this part of the river. Whereas in the head region, it is mostly flowing through the bedrock, so the chances of shifting of river is a little bit difficult, or it is not that much easy to shift the river. Rather, it will be more eroding, and deepening of the valley processes will be active. Okay, so this is the general idea about the geological character of, or the longitudinal profile of a river, or longitudinal profile of a river, which shows three parts: head region, middle region, and mouth region. And the activities of a river is more dynamic in head region, and as it going down, it would become mature, and the old head region, it is called the youth, and the middle region we call it as the mature stage, and the last stage where river is more in depositional in nature, that call it is the old stage of the river. Okay, so this is the longitudinal profile, and here I'm talking about some of the terminologies which are associated with a river. A river stream is nothing but which is a surface water flowing in a channel of their own. So there are well-defined channels. The river is established a channel, and that is called a streams. Okay, so a river is what? It is a large stream flowing through large area and receiving other streams from sides is called a river. So if you see here, this is a stream, and these streams meet to one major stream here, and this is another stream, and this is another stream. These streams meets the large river. So this we call it as a river, and these are all the streams. And other than that, during the rainy season, during the water raining season, there are number of small channels which may be developing here all, but these are not called still streams because this is not a permanent feature. This stream which is producing is not a permanent feature. Like if you see here, there may be some streams flowing here, water from here, it may be contributing to this river, but this is still not a fixed channel, so that is not called a stream. A tributary is nothing but a small channel running to a large river. So streams are also called sometimes tributaries because that particular stream contributes to a major channel. So drainage system is actually the connection of all these streams and rivers. Collectively it called a drainage system. For example, this is one drainage system which includes all this. This is a one single drainage system. Okay, so this is what we call it as a drainage system. That means the water flowing on this part, all this will be contributing to this river. Okay, so this boundary what I have drawn here, this boundary what it indicates, a water which is flowing on this part will be contributing to this river is called the drainage basin. So every river will have a drainage basin, that is a topographically divided portion from where a particular river collects water. Okay, so in this stream, if you see a water which is flowing on this part, it may not be contributing to this river. Rather, it will be flowing through this river. There may be another river flowing here, and that will be contributing to that river. So that river will have another drainage basin. So drainage basin means it is a region from which one particular river collects water. Okay, so that particular boundary or the topographical barrier from which the water collects is called a drainage basin. So to make you little more clear about this drainage basin concept, I am just sharing another screen. Just one second. Right now, what you are seeing on the screen is our part of the Gujarat. We call it as a mainland Gujarat. And there is one river which is flowing here. This river is called Narmada. And here we have Tapi. This is Sabarmati river. Three rivers, major rivers, and Narmada become one of the major west flowing river in the Gujarat or in India. Correct. If you see the Narmada river, which flows through this part, it is in the Madhya Pradesh. Are you able to see this part where is a hilly terrain which is flowing through the Madhya Pradesh and which comes into the Gujarat alluvial plain? We call it as an alluvial plain. And this is what I was talking about in this part. The river is taking, just 1 minute. In this part, the river is taking, so in this part, if you see, the river is taking a general topographical flow, and it is flowing through the mature stage. And if you see, these are all the meanders. Okay, so this channel, this is what I was talking about. The river doesn't flow in its mature stage. It doesn't flow in its one path. There are number of areas where it is changing. See this part. If you see here, there is a change in the river. What happens to the river? It shifted from this bank to this bank. Okay, and in this part also, if you see, the river is shifted. Similarly, if you see this part, the river shifted from this part to this part. Northern shifting and southern shifting. So this is actually the process of the river. And if you go to the mouth portion of the river, we can see that the river is now meeting the Cambe, basin Cambe, and here it is the part where it is more depositional, and you will see number of depositional features here. Okay, so this is one thing, and if you are talking about the drainage basin of this river, this is what we are seeing the river right now from a top view. Now I'm going to show you the 3D view of this river. Just one second. Okay, so this is the three-dimensional view of this river, and if I see this river, we can easily understand that how the changes are happening. See, this is a plain region, and if you go towards the river, it is coming out of a large hilly region, correct? So in this hilly region, what happens if there is a rain and water flowing on this part of the hill? Let me just reduce the height of this, so it will be easy for you to understand. Now you see it is very clearly visible for you. Now we imagine the water flows on this part of the hill. Are you able to see my cursor? So this is a boundary, a topographical boundary. So water flowing on this part, on the left hand side it will flow to this river, and the right hand side it will flow to other river. So this become a topographic barrier for it. So it is actually the topographic barrier. We are marking the topographic barrier, then we call it is a drainage basin. So drainage basin is one of the important aspect for any civil engineer, because there are so many different number of features a civil engineer do construct across a river. For example, the dam, Narmada Sardar Sarovar Dam, which is constructed on this part, and you know that below that there is no topography which can hold so much amount of water. So this is the best place to construct a dam. And this whole area now it is under water because of the dam which is filled with water. So we can see that a beautiful valley which is preserving all the water within this. And as we see that the Narmada, then it is flowing all through from the Madhya Pradesh, and all water which is transferring from all this region will be contributing to this dam. Okay, so this is the feature of Narmada, and if you want to see the cross section, that how the height varies, for example, I'm going to do is, see, this is the river, okay, and what I'm going to make a cross section of this river, and now as I said, I reach the hill. Okay, so you see now how the variation of the river is. Okay, so where I'm going to talk here, this is the region where it is on the floodplain. What is the elevation here? It is almost 0 meters. See, the river is flowing almost 0 meters to 45 meter to then slowly increasing. Then it is going to the highland where it is flowing through the hilly terrains, and the elevation you see now, it is 204 meter, 118 meter. Then it increases 176. It goes up. See, this is how the variation of the height. So the elevation of this river which is flowing from Madhya Pradesh is goes from 500 meters to around 0 meter elevation. Okay, so this is what a river. So obviously the river which is flowing on this part, which is basically more erosion feature in nature, but in this part where it comes to the alluvial plain, it will be more depositional in nature. Any doubt in this part now?
No, sir.
Good. Okay, so now these are the terminologies what we have discussed. We have seen the river in its different stages. Now what we are going to see is that what geological activities these rivers are doing. Okay, so any river which is flowing, which will be doing three main processes. First process is called erosion, second process is called a transportation, and third process is called a deposition. Erosion is nothing but this is a bedrock. Bedrock means it's a rock over which the water flows, and here in the top it is the this is the air. Okay, this is atmosphere, and this is the boundary of water. Okay, and this is the boundary of the rock through which the water flows. So this is a rock portion. This is the water column, and this is air. So water, when it is flowing through this surface, there are number of small areas where these rocks will be having some fractures or some surface features. which will enable this water to weather. Weathering is what? It is actually a detachment of material from the surface of any solid rock. Okay, so this detached material, this process is called weathering. Weathering doesn't remove the material from the surface. Rather, weathering will produce something that will be slightly detached from the surface of the rock. Now, this water which is flowing here, it will put some pressure on this weathered loose material, and that will be picked, and that will move from one portion to another portion. Then the process is called erosion. Correct? So this eroded material will be transported by this water in different modes. Either it will roll, if it is very heavy, then it will just roll down. Okay, sometimes it may be taken into suspension. So this all processes we call it as a transportation. Okay, so this is erosion and this is transportation, and deposition I am not showing here. Deposition is the feature where this transported materials will be deposited somewhere and it will produce some landforms. So that process is called a deposition process. So river do all these processes. What are those three? Erosion, transportation and deposition. Okay, so the geological action of river for a civil engineer, these three processes are important to understand. Where the rivers are eroding, where the rivers are transportation is not very important, but how it is transporting, but where it is depositing, which is the deposition end, which is the erosional end, and which is the transportational features of a river. So that is what we are going to see one by one. First one, let us see the methods of erosion of the river. Okay, so when you talk about the methods of erosion of river, there are three main processes. In fact, there are four main processes. One is hydraulic action, second one is abrasion, third one it is called attrition, and fourth one it is called corrosion. Okay. These are all simple processes. First one, it is hydraulic action. This picking up of the sediment is by the water. There is no other agent which is involved in picking up this water. So this is what the process we call it as a hydraulic action. So hydraulic action is the mechanism of losing and removal of rock by water. So this is called hydraulic action. So sometimes in the case of waterfalls, we usually see what this is a waterfall, and the waterfall, when the water flows from this height, which mix with the air, and it creates some depressions or the erosions in this part, and this process we call it as a cavitation process. Okay, it's a water and the air combined together which erodes, we call it as a cavitation process, and this is a subpart of the hydraulic action. Then there is a process called abrasion. Abrasion is what? Abrasion is the eroded material. Now there are materials which are eroded by the river, eroded by the water. There are materials which are eroded by the water. Now this material, this sediment, we call it as a sediment. This sediment which collide with the sediment will produce small pieces of fractions. Okay, so this process, water and the sediment together will hit this part and it erodes the material from here. That process is called a abrasion process. One is collision between this, that is one, and this eroded material interacting with this, that is another portion, and this collision of sediment and the water together, when it's erode the material, we call it as a abrasion process. It's nothing but water is having fine grains of some rock particles. So when the water hits the rock surface, along with that there are some grains also hit the rock surface. As a result, the erosion processes will be more, and that will be more active. So that process we call it as a abrasion, whereas the breaking up of materials by mutual collision is called a process of attrition. There are two materials, two sediments which are eroded already. Now this sediment, if I move along with the water and hit on this, then these two things will hit together and break into four pieces. So that process is called a attrition process. Okay. So that is attrition, and solution activity, which is nothing but the chemical process. So dissolved materials, and you see water at our home, this water will not have any sediments within that, but if you pass that water through a filter, then we'll see that there are so many materials coming out. So these all things are dissolved materials in the water. So that is a solution activity. So these are the three main processes by which a river do its erosion. Correct? So what are the processes? First is hydraulic action, then abrasion, then attrition, then it is the corrosion. Corrosion is the chemical action and it produces a solution. So it dissolves in the water. Okay, so I think we have 10 minutes left. Let me just go through the next slide also. Okay, any doubt till this?
No, sir.
No, sir. So one more thing, what we are going to discuss here, it is the rate of these erosion processes will be basically depend on number of parameters. Number one, it is velocity of the stream, and velocity of the stream is also not uniform in all the parts of the streams. For example, this AA is a cross section of this section which is showing at this part, where in this end, if you see, it is mostly a depositional low energy condition because the river flows in this way and the major energy coming to this center. So this is the part where it produces high velocity, whereas in this part, whereas towards the stream it will be less part. So the point is that when the river flows, there are different areas will have different velocity of stream. So where it is having more velocity, it will erode more. If you remember the first lecture, the introductory lecture, I was talking about the Baruch erosion process. That is this criteria. When there is a more velocity, there would be more erosion. Where there is a less velocity, there would be more deposition. Correct? So this is the process it happens. So velocity is one part which controls the erosion nature of the river. Second one, it is the lithology of the rock. If the rock is more stable, hard rocks, then there would be less erosion. But if the rocks are of loose materials, then the sides will be colliding more easily and it can create more wider channels. As a result, the velocity decreases, more deposition will happen. So that kind of dynamic system is there. So lithology of the rock, there are some rocks which are very easy to erode, but there are some rocks which are not easy to erode. So the rocks which are easy to erode will produce more erosion, but whereas the rocks which is resistant to erosion will produce less erosion processes. So velocity is one thing. Velocity is also controlled by the shape of the river. If it is a narrow river, then it will be more faster like this. Here the river is wider, but when it comes to this part, it is more narrow, so this portion will erode more. So similarly, when there is a lithology easy to erode, it will erode easily, but it is a compact resistive rocks will produce less erosion process. And last one, it is the load. Load is that the carrying the materials which is carrying by the river. So if the river is already carrying a lot of materials and it is not having a capacity to erode more, the erosion processes on that river would be less. So depending on the load, if it is not having any load, it is not having suspended load, or it is not having any materials carrying by the river, so it will have more energy to erode, and the processes of erosion will be more in the case of rivers which are less in the load. Okay, so these are the three main processes which controls the erosion. And if we see that all these processes together, will produce number of different geological features in a river system. So that will be the topic we'll be discussing in the next lecture, that is features of stream erosion.